Okay, hello everyone. Welcome to another Wolfram Language Design Review as we get ready for version 15. This is about control and system modeling. So, you told me to update my documentation and I didn't do that yet. So let's go ahead and do that. Can I pull up this page yet or not?
Those reference pages, whenever you're, up to date, you can pull them up.
It'll take a little while to get up to date. So maybe we should talk through what this is all about.
Yeah. Okay. So these are all using sort of neural net.
Here. I'm sorry.
Oh yeah. So that's a little bit different. But the key things that both of them are sort of using using sort of neural nets. So the first one for system modeler, the surrogate, what that will do is to provide a neural net. You train it, but not on data, but on a model. So you have basically infinite data.
And you have to using reinforcement learning, or is it just doing what is
just
it doing?
training? That one is not using reinforcement learning, I think, but it has a particular style of model that's good to model these types of dynamic systems. So you can model some number of parameters, and parameters can be initial values or just parameters.
So if I just took a regular differential equation and I said, do this, would it work?
Yeah. Ordinary differential equations, like one independent variable.
Okay, so I mean, why is this? This is freezing.
Sorry?
This document is freezing. I don't know what all that junk was down here. But something froze in this document, just saying.
I think
I opened it.
Yeah, sometimes it does take time for updates. That depends. It happens in all kinds of different ref pages that it needs to get, the front end needs to load things and it takes a little while.
So I'm not thrilled with the name surrogate, especially since you were talking about, I mean, this is basically a system model, basically.
Yeah, yes.
Um,
And we will have more of these over time. This is one. I believe that we're gonna have, I don't have one that we're gonna do right away, but I believe that we're gonna have more kinds.
Of what?
Of surrogate mod. This is a particular technology, the CTSN, continuous
but
time.
that should surely be a method option. I mean, we want a general mechanism.
Right. Yeah, and this is the general mechanism.
Well, let's make sure that the mechanism. Okay, so then this, I don't understand. Is this the range of values it can have?
Yeah.
So this is a spec, basically. I mean, it could be a statistical distribution. It's a spec for a range of input values. I mean,
yeah, because you're effectively going to build a function that can take
I'm aware. Yeah,
okay.
Right. I mean,
Yeah.
you're basically, it's like computing, so okay.
It's the domain for a function, but it's not a statistical. It's not around.
I understand, but so, okay, multiple points. Active classification, that function has a mechanism like this, does it not?
I'm not sure.
Well, that's something we need to look at, right? Anybody know about that here?
No, we've not looked at active classification.
Okay, so you should. Right, so it is doing something where it's been given a function and it's being told so this is doing something very similar. So we kind of need to figure out how, I mean, maybe we should maybe somebody could see if Julio is around.
Yep, I'll try and find him.
Thank you.
We did have contacts with Julio and so on, so he didn't bring this up either, as far as I know.
Well, I understand. He wasn't much involved in this function. It's not been one of our more successful functions.
Okay.
But it does have a definite design pattern.
Right.
Okay, so the concept here is let's what the heck? Oh, okay, so here we go. Got a model and a spec there.
Mhm.
So what is the relationship between this progress monitor and the uh, um, the progress monitor that we have in NetTrain?
I mean, this uses the monitor framework. There's nothing to do with the NetTrain
But so it doesn't
specific.
have a loss that's going down and things like that. It must do.
No.
How
I
does it
mean, it
work?
does, but this one, the progress monitor doesn't show that. Is that what you mean, or
Yeah, this was very fast. Was that because it's running on 200 cores or what?
yeah, that helps. So the simulation is completely in parallel.
Okay.
You know?
But so what is it doing? I mean, to what extent is it? So it's not using reinforcement learning, so it's just laying down a net of things within that interval.
Yeah. So Sergio, do you want to explain it in detail?
Right, yes, it's just sampling that interval and putting together the data. And
How
for the
many samples
training,
does it use?
by default, it uses 200 simulations.
But each simulation have many time values.
And where do I set that number?
In the spec, there's a simulation count uh, chapter. Mhm.
Okay. But if I had many parameters, it would distribute that simulation count across those parameters, right?
Exactly, yes.
The thing that I said about distributions wasn't as silly as it sounded, because the fact is, you could want to sample more in some region than another.
Oh yeah, the success distributions. You can pass that center interval could be a distribution there. Yeah.
I see. So that could be if I say normal distribution.
But does it affect the sampling?
Yes.
Okay.
So I'm kind of curious to see what happens if I have a thing with mean 1 and variance 1, which of course will go negative, right? Resistor is not known for going negative. But let's see what it does. I like this progress monitor. Now, this is not an adequate piece of progress monitoring. See what I'm saying? Just saying training model with no action going on doesn't
It's
make
too boring.
What's that?
It's too boring.
Say it again.
It's too boring, right?
Yeah, yeah, but it needs to show something that shows progress, and especially since I have 200 cores running here, it's going to be a lot slower if I don't.
Right. No,
Now,
I can do better. Yes.
okay, the
Mhm.
way that parallelism started up was not the most wonderful thing in the world. There's no control here of how the parallelism works, right?
Right.
So I don't know whether we have a pattern for that in other functions. Roger, do we?
No, that's what we need to establish. So we don't have it and it's not for 15.0, but establish those policies that you can do some
I
more.
think it should be parallelized arrow true or false or something, or parallelized because it's like we have the compiled option, for
No, but I
example.
meant for the pattern, like you worry about sort of, you probably don't want all the 200 distributor. You probably only want the local machine or something like that.
Yes, that's right.
Okay. So that needs to be a policy thing that you set so you don't have to set it all the time.
Oh, I understand. I understand. But so what I think it should be is some kind of parallelized option, which could be sort of automatic or something, or true. I'm not sure exactly how that will be set, but I agree it should be, dollar parallelized or some such other thing.
So I think we need to work on that for 15.1, but it's just,
Okay, well,
we
so
need to
it
see
would
a
be,
few
I mean, this
cases.
should
We
be,
need to see more than one
no, I
case.
understand, but so please flag that, and it's something where the existing, there are now in launch kernels,
Mm.
there are now various kinds of things like local, for example,
I
or
see.
one kernel per machine, right? Where is it? Wait a minute. Where the heck? Oh, there we go, local. But that's not correct. That's just wrong. That's wrongly documented. That launches all kernels on the local machine. Tracy, are you PMing here?
Yes,
Can you please raise that with Arnaud and Roman?
sure can.
It's just pathetically badly documented. And this table should be broken out between local and remote stuff.
Okay, I'll tell them.
Otherwise, nobody will ever be able to tell what the heck's going on here. Crazy. All right. In any case, that's a pattern for what we will be doing here, right?
Mhm.
Whatever is the launch kernels option, and there's a $default parallel kernels, which presumably you are using,
Yes, yeah.
right? So if $default parallel kernels, you should document that here, is set. You should have a value that is an option that is, I mean, I don't see why you wouldn't just do this right away if we can come up with a name for it. The option that is set to $default parallel kernels by default. Do you see what I'm saying?
Yeah. But I don't know what all functions are that need this. This like no way.
No, there are
no
more
way.
functions than this, but we could start with this function since we know we need it here.
Yeah.
I mean, we should inventory what, I mean, that's a good LCC topic. Can we inventory what functions need this? But let's come up with a name for it. I mean, the obvious name would be parallel kernels, I would think. Well, I don't know. This requires maybe bringing this up. I think we have a Tracy, can you get some appropriate meetings, small number of people that are involved in this, please? And let's solve this and get a
Yep.
name that these guys that Sergio can use. Okay, let's come back to this. Okay, so now I have this surrogate model. I don't like the term surrogate. Oh my gosh. What's all this? I mean, why do I have to pick out the parametric function? Why is this not plug compatible with the model? I don't understand. I'm very confused here. Why is this not? This is like a system model, right? So I should be able to say of that thing.
But it only models a few of the many other signals.
Okay, but if I say system model plot of this thing, it should just work, right? If it doesn't, it's wrong. Yeah, it's wrong.
Yeah. I guess we
Well-
can make it work.
It needs to work. I mean, it needs to be, look, what it should be is
No, it's fine, Stephen. We could
like a
make
system
those.
model.
Yeah, but
Right.
so system model, what we've done is to curated default plots, basically.
I
Like,
understand.
Even if there's 1,000 signals, we say that this one or these two are the, standard or default. And we could do that for this one too. We could automatically do that.
Yeah, I think so. But I mean, but I think that anything else that works for a system model,
Mhm.
it's kind of like an interpolating function. Anything that works for a function,
Yeah.
should work for
I mean, this is a convenience. It's not the formal definition of what these things do, but it's fine. We could do the same
no, okay, I
convenience.
understand. But we shouldn't need to have all of this gunk here.
Well, you do need to set the resistance, the resistor, because this model is valid for all possible parameters.
I understand, but so why aren't you setting it in the same way? So in other words, you say system model plot of the surrogate model and then the exact same arguments here.
Yeah.
Okay, we agree. Yes,
This
Sergio,
thing,
do you agree?
Yeah,
Yep.
I think we should do that. I think what it used now is parameter model, parametric model. That
I know it's parametric function. I see it here, but
okay.
this is CRUD that you shouldn't need to do.
Yeah, but then we probably need to think. Then we probably need another head. We probably can't use parametric function anymore.
For what?
We can't output a parametric function anymore because this is how parametric function is documented to work, and that's how it works.
I understand. I understand that.
But you want it to
I'm-
work
I'm-
differently, like system.
No,
model.
I'm not. I'm saying that what with this thing, surrogate system model surrogate,
Mm.
should work like system model works here.
Yes, but that's not how parametric function work,
But
which is an
what
old
does
function.
parametric function have to do with it?
We used it, but we don't need to use
No,
it.
no,
We
I
can
know.
use-
So this example should just say surrogate equals this thing, train, whatever, return system model surrogate, and this thing here should just say it should say, instead of this, it's none of that stuff. It would just be this, none of that. It would just be that with whatever the name of the surrogate.
surrogate.
Yeah.
Yeah, I agree with you.
Yeah, okay, fine. Then we agree.
Yeah.
But
The other thing we can still maintain, because it's a bridge to the workflows as we have for parametric function, which is also useful.
no, I
Meaning you-
agree. I understand that's
do-
useful. And you can get a parametric function presumably out of a system model here. I could say here.
No, but you could get it out of the surrogate model.
No. It's got to be the same, right?
What do you-
Why can I not say parametric function here?
Well,
what-
you
what
first
that-
have to simulate the
Well,
model.
Why doesn't it do that rather than just giving an error? This is not the right thing for it to do, right?
Okay.
I mean, it's just completely wrong. It should just
I have to
compute
think
it.
about that, whether it makes sense to even produce a parametric function.
Well,
What
then
the hell
should,
would
it
it
should
do?
make an
We
error.
have often thousands of parameters for a system model. I mean, it's like,
Well, so what does it mean then to produce a parametric function? Why does that even make sense for any of these things? It's because in the case of the surrogate, you happen to only be scanning over a small number of variables, right?
true. Yes, true.
Okay, so that fact, you should be able to look, in my opinion, what should happen is instead of using crazy subvalue stuff, you should be saying something like parametric function of the model, and then I don't know how this should work. The model. And the variables.
No. Parametric function has its own world, It is let's get rid of parametric functions to just not have this discussion.
Well, no,
Yeah,
it's a
Let's
documented function,
restrict the functionality and not get there.
Oh yeah, this is a completely different thing.
Right.
Yeah, this is a different thing. Being able to get a parametric function out of a system model or a surrogate system model seems useful, but to my mind, that would be that's not the right documentation.
Where are you looking?
This at the top here. Where's the actual payload?
This is an output function. There is no input.
Where is it on this page?
This is like
I don't see it.
interpolating function. There's no way.
No,
that
but okay, so here. Oh, I see what you're saying. That just has a payload inside it.
Mhm.
By the way, this is a very inadequately documented page. You should add that. Tracy, can you add that to the under documentation list, please?
Yes.
Why is this different from, that doesn't seem like the right documentation. It just should be parametric function of dot, not pars dot. Oh, no, I see, because it does have parameters.
Yeah.
I'm finally understanding. Yes. And that's why it's different. But what's the dot, what's the for here? Is that two parameters of this
The
function?
two parameters. You can see parametric and dissolve above. It lists at the very end there's a list of gamma and omega. Those are the two parameters.
Okay, all right, okay, fine. Okay, look, it seems to me a highly useful bridge between the function world and the system model world to be
Well,
able
you can't,
to.
but we would have to really think about that. It's because you have to restrict it somehow. You can't, the system models are just of a different level
No,
of complexity.
I understand that completely, but the whole point is what you're doing in this system model surrogate, you're doing these kinds of scans over small numbers of variables,
Mhm.
right?
Yes.
You are extracting, I mean, in a sense, system model surrogate is in many ways extracting the parametric function. That's what it's doing. It's not extracting the full space of all possible, variations. Is that not correct?
Right. Right. You select which parameters and which
Right. It's like a
variables.
tangent. It's a tangent to this giant sort of function. It's just in a particular direction.
Kind
It's just an analogy. Yeah.
Yeah.
So okay. So
let's
here.
I think that one thing to go back to before we get too caught up in the administration stuff is that why? Why do we even want this?
Oh,
Who
I
cares?
think it's obvious. Why it's a good thing. It's a much more efficient way of
Right.
evaluating some piece of a model. It's
Exactly.
a good thing to have. And
Yes.
also, I'm sure it's useful as something that you can manipulate with sort of wild abandon, like a function, and differentiate and do all kinds of things like this. Right?
Yeah. I mean, it's slightly limited because it's hard to differentiate some of these neural nets.
Yeah, well, it gets easier as our frameworks get better.
Right.
But I have a question. Why does this not sometimes end up with an interpolation function? Why is it always, can it be a zero parameter parametric function?
Yes.
And in the when you create,
but I don't think we should do. I mean, interpolating function a piecewise polynomial. I think we should stay within the same framework of representation. I don't think we can give any guarantees for interpolating function. If you so want to, why don't you use function interpolation on top of that if that's what you desire? But I don't think that's what we should do.
okay,
but
let's look at the directions we're going here. Okay.
Mm-hmm.
So first thing is system model has all kinds of functions: system model plot, system model simulate.
Yes.
And all these things for doing, all these sort of control stuff and lots and lots of things.
Yeah.
Okay. So this is an approximator, just like N is an approximator of things.
Yes.
And it's a new kind of approximation because it's an approximation only with respect to some variables.
Mm-hmm.
Right.
But also,
but
it's also, I mean, in some ways, it's more general and more restrictive. So it's continuous time. It deals with, let me see. It is a particularly suitable neural net for this. It's a type of recurrent neural net, but also,
that's how it happens to work inside. I mean, I don't think anybody cares if it does a good job of representing the function. Nobody
that's
really
true.
cares
Any surrogate, people, that's right. As long as the surrogate is good enough for what your goal is.
Yes. So the fact that it's a recurrent neural net is just entertainment value. I mean,
yeah.
it's
yeah, to some extent. Yeah.
Right. So if I retrieve
but there are a lot of them that don't work well. Just what I'm saying, you could easily specify something that don't work particularly well.
Specify something in what regard?
Like a neural net that doesn't work particularly well for this class of models.
Oh, sure. I mean, if I say %7 sub, I think it should just be called net. That will be consistent with what the other things we're doing, right?
Hmm.
Okay, that's nice. I think it should just be called net. I mean, that's cool. That's very nice. And that will be useful to people. But now, I think you should make this work if you didn't already. Yeah, you should make that work.
Okay, I'll talk to Julio, I guess.
Yes,
yeah.
yes,
okay.
yes, yes.
Mm-hmm. Yeah.
I mean, that's pretty nice, honestly. Okay. So here, what's the consistency between this and a layer specification for a net? The layer specification for a net has output layers. Do you understand what I'm asking about this outputs thing and so on?
Mm-hmm. I mean, these refers to the outputs from the original model. So we have a concept of outputs and inputs for system models, regardless.
I understand, but I'm asking if we look at linear layer, for example, there is a way of specifying, following ports for use
Mhm.
in NetGraph. So what's the consistency between this and that?
Well, I mean, they're called connections in system models, connectors.
Yeah, but what are we naming them? Because here for a neural net, we've got this notion of an input array and output array. It's a little different here.
It's a little different, but the concept of input and output for these systems exist.
Yes. Okay. So, okay, fine. What alternatives are there to the word surrogate? Approximation.
Yeah.
Surrogate suggests that it's the whole thing, and it's not.
No, it doesn't
variables.
necessarily do that. One thing that it suggests, the use of surrogates in optimization is to have a usually what it suggests is significantly cheaper.
Okay. But is it the only word that's used to mean that?
As far as I know, but we should.
But is it a commonly used word?
Yes, it is. I guess another name, I don't know, it's very common. It's proxy, but it's not, doesn't quite mean the same thing. Yeah. No, it's not. I don't think it's used actually. So.
And I mean, this notion of a surrogate model is also relevant in other places like PDEs and so on, right?
Yeah, yeah.
How do we think that's going to work?
I don't think we're ready to even tackle that.
But let's talk about it for a second, just to understand the syntactic
Well,
structure.
I think that sort of what we're getting to, and if you look at the applications, I mean, maybe that would be put a system model surrogate train, or yeah, look at the applications there. So a lot of what we solve here are optimization problems.
Mm-hmm.
And I think that that's similar that can come up for PDE models, that you want to optimize some property, So in this case, we're optimizing parameters. We can also in the future have where we optimize out and find whole functions, not just parameters. So functional optimization.
Right. But so just so I understand, I mean, the basic point is there's this very high dimensional, many variable, highly multivariate model.
Mm-hmm.
And you are making a surrogate that is essentially this tangent in a particular direction. It's particular.
Or subset. Yeah.
Right. You're holding many variables fixed. You're giving those as parameter values here.
Mm-hmm.
And what tells it which things are variable?
The outputs, inertia.
But where's the input? Because that's what, when you're scanning over values.
Well, so that's one of the things that this surrogate can't deal with inputs right now. So we need a different style surrogate model to be able to deal with input functions. And so inputs here means input functions, not just input values. You need a whole input, like in control, you need a whole input function.
So hold on. You're saying, but I mean, there's initial conditions and things like this. How are those?
Yeah, those are values. So those are those parameter values. So initial conditions are treated as parameter values.
Okay, and how are they named? I mean, like resistor is the same for all time, but how do you name the initial, the thing that's true only at the beginning?
Yeah, so we have a key initial values, and then you can just set the initial value for the variable.
So instead of parameter values, you've got initial values.
Yes.
Okay. So, okay. So that's what you feed into the surrogate train thing. By the way, I really hate the way you're using all these variables and things to set this up. It really should just be system model surrogate train of the model, Bloomp, and the spec right there. Just makes it just much harder to read the documentation. Just
Okay.
saying.
All right.
What I don't understand.
I'm saying what the documentation should have in it is so you're not searching 17 lines to find what
No,
the
but
thing
there's
is.
like there's a grammar. You can't do it.
Well, you can do this in the first documentation example. What's wrong with that?
In the example, yeah.
Yeah, that's what I'm saying.
Oh,
In the
that's what you-
example, don't
that's
make a bunch
No,
of
no, no, no.
variables you
No,
don't
no,
need.
that's fine. The only time we make variables is when we're going to reuse it.
I
Or when
understand.
you want a piece of textual explanation around it,
Yeah, I
which
get
is
it.
also good to have it separated.
Yeah. I mean, I think it's important for people to just see, boom, you can use this function. You don't have to write 17 lines
The
of code.
multi-line inputs are very hard to read.
I don't disagree. I mean, I think they should be avoided, but I think it's important when it's a function, it just has particular things inside it, like this, for example.
Yeah, if
You
we can
get the
make
idea.
as simple as this,
Yeah,
absolutely.
right. Okay. In
Absolutely.
any case, all right. But let's come back to what this is actually doing. So
This is
think,
kind of a manual example. Sometime in the future, we'll have a function that does all this in one line. Okay.
okay.
But right now, you kind of have to do the optimization yourself. Do you know what I'm saying? We just provided
Yeah,
in
I
here
got it.
a function that's easy, fast to evaluate.
Right.
So there's an application for that.
Okay. So what this is doing is it's saying you're going to scan over the initial values.
This one says that the function of time that I want to have this function provide a surrogate for is the inertia 2 dot omega, as a function of time.
I understand. So this could be just an interpolating function, in fact, the output. Just a single variable as a function of time.
I mean, it comes from the system, so it's derived from how the coupled differential equations in there.
How do I get the result at a particular time? So let's say I have a surrogate system model.
Mm-hmm.
How do I, in an ordinary system model, like this one here?
So normally when you do system model simulate, it will return interpolating functions. So you have an object and then you say, which one do you want? Because as I said, it can be, do that. Now the problem is there can be many, right? So now you can say, which one do you want to pick out of all that data?
So why is system model simulation data? Isn't that the same kind of a thing as what you have named here, system model surrogate?
Sort of. Yeah, it's similar.
And how do you extract things from this?
You can just pass the name of the variable.
Give me an example.
Like inertia 2 dot omega.
That looks like a W to me.
Oh, W, yes.
Yes. Yeah, there's no Greek letters. And now you're back to I'm saying all the workflows that you used to for that. We've just provided convenience, like system model plot, both simulates, picks out the thing to plot, and short circuits many steps.
Okay, all right. So, but if I took system model simulation data and I say of that,
you can do system model plot of that.
That's what I was going to do.
Yeah,
so that will just work.
Yeah, it will just work. Well, maybe not that, but if you say what you want to plot, but maybe that
Why do I need
work.
to say that? I think this should work.
This probably should work too, Sergio. Meaning, if we have this thing of standard plots, maybe system simulation should maintain the same standard plots.
Right. When the model has a stored plots, then we just show those plots automatically.
Right. The stored plots. Yeah, we could propagate that.
Okay. So let's see. We got to get some consistency here. System model simulate returns system model simulation data.
Yes.
Yet system model surrogate train returns the surrogate model thing.
Yes. Well, no, I mean, it returns to, yes.
What's
yes,
the
model.
difference between system model simulation data and essentially just a system model in terms of how you can use it?
System model has all the differential equations, basically, like this
No, I understand
huge
inside
network
it.
of coupled
But I mean,
stuff.
if
This
I say
thing-
this and I
this
say
thing-
inertia,
Yeah,
that
it's
doesn't
not.
work.
Yeah.
Yeah, it's just not.
It's not, it's nothing to pick out, if you see what I'm saying. It's
Yeah,
like
no,
this,
I understand because it's an unevaluated thing.
right? It's an unsimulated thing.
I think it should give a message there that says you need to simulate it first. Can you do that?
For an arbitrary string, I guess I could.
Well, if it's not an arbitrary string, if it knows it's a variable,
Okay.
because it
Yeah.
certainly knows it's a variable because it can get a list of variables, right?
Okay. Mhm.
Just a courtesy message to help people. So, okay. Now, in general, with this output surrogate model, it
Mhm.
could have multiple output variables. Is that not correct?
Yes.
So if I wanted to get the interpolating function for one of them, I do it with a subvalue like this. Is that correct?
Yes, but you need to specify the parameter as well. So that was the value of using parametric function, because you specify the parameter and your variable, and out pops an interpolating function.
Wouldn't the
Which is,
natural thing to do be to say system model surrogate data? Oh God,
Maybe.
I can't type there. Ah, it doesn't let me type in this place.
yeah, maybe. Yeah, that's perfectly fine.
Because that will then be exactly the same usage as this, correct?
Yeah.
Together with the parameter value, you mean, or?
You need to specify the parameter. Yeah, so we've deferred. When it's like numerical simulation, you can't simulate with unknown parameters. Parametric NDSolve can simulate with parameters, and then you have sort of this two-step process. Given the parameters, it runs the simulation and you get the interpolating
Well, okay, I
function.
understand. But so what are you saying here? So this one here has, you're running. This is utterly obscure. I wish you wouldn't have done it this way in this example. I mean, this is so obscure. I have to take apart this whole pile of crud in order to see what's going on. Just show me this and then show me the other thing.
Okay.
You know what I'm saying?
Mhm.
Okay, so you're giving the 0.4 and then the time here.
Yes.
Mhm.
What's the analogous thing for time here? Can I say this?
Yes.
Yes.
Yes, so then I can say plot that t0, 10. Okay. So what you're saying here for the surrogate data is you've got the innards, and then you've got the variable. Is this right? And then you've got the parameters, and then you've got the time. Is that right?
I mean, that's not what we have now. So like for parametric function, you got the sort of the innards, the params, and then time.
So if I take this parametric function,
Yeah. I'm not sure you can do that because it's not in the notebook.
that wasn't saved. Okay. Okay, but what do I do to use that function? Here you're just giving one variable there, one value. Why do you only need to give one value?
Because it's only had one parameter.
Where's the parameter? This thing here?
Yes.
But so in general, I would give an association, resistor, blah, 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 arrow 0.4, something else, arrow something else. Is that correct?
Like in parametric function, usually if there are several parameters, you just pass the values in order.
I know, but that's not right for this case, is it? Because you don't have any idea. I mean, are you really
No,
stripping
I
out
think
the
that
names?
I think Stephen is right. I think one should probably have more fully qualified. And at the time we did parametric function, I don't think even think
No,
we
we
had
did. Yeah, right. It wasn't relevant. Because,
Right.
but now,
Well, we didn't even have associations, I think. So it's like,
maybe we did just, but it doesn't really matter. But anyway, we were not thinking of things this complicated. We were thinking of things where you're solving an equation and everything is a position, is a
Yeah.
positional argument. Okay. So hold on. So what you're saying is we get this thing out from the training, from the surrogate model training. So system model, what you might be calling system model surrogate.
that's what it's currently called.
I understand. Now, for system model itself, how do you give additional, if I have a system model like this one here, and I want
Yeah.
to say the resistor is 0.4, whatever it is, how do I do that for that model?
You can use set system model.
Nah, that doesn't, you're out of the game. Because it's inconsistent with what this is doing, isn't it?
I mean, you can set the parameter values in the various functions that use it. So system model simulate, you can set the parameter, system model plot.
How?
With the association like this one, like parameter values goes to.
So exactly like this one.
Yes.
Exactly like that one.
Yeah. So you can just switch system model plot with system model simulate.
Okay. But so what this is really saying is, let me think. You're given a surrogate model for which you then may have to set more things.
Yeah.
Right?
Because you want you want that flexibility. Otherwise, interpolating function would be just fine.
I'm wondering if system model surrogate itself. Okay, let me try an idea. Okay, so system model surrogate. And then you feed it in a standard system model and it goes and grinds, and its parametric information, right? Like this. Okay. And then it returns a system model surrogate, not something else. It just returns that. And then if you want to further specialize, you say system model surrogate of the surrogate model, comma, and then whatever it is, this thing here. You see what I'm saying? Well, it isn't that anymore. It would be something like this, arrow 7 or something. Am I making sense?
I see.
And that would then return itself another system model surrogate. Now, when you use system model surrogate, it has to work exactly like system model. So if you want and if you want a function out of it, there is a way, right, to get a function out of system model. Once you've done the simulation, you can get oh no, you can only get a function out of system model simulation data.
Yes.
Right?
Yes.
Right.
Okay, so in this case, okay, so here's a suggestion. If we could get a function directly out of system model, implicitly doing the simulation, then we would have something consistent. So I'm saying, so system model surrogate.
But you're gonna have to, I mean, you're still gonna have to have controls for how the training is going.
That's fine.
Yeah.
That's fine. System model surrogate can have oodles of options.
Okay.
The point is to have something where you can go and keep refining. You know, how do you keep refining? That's the point. You don't want to refine at the stage where you're doing all this messy stuff here, where you have to take it out and then, you know, mess it around there. You want to be able to refine it in the same way that you've given the original input, I think. Does that make sense? But now let's talk about what comes out, right? So system model surrogate comes out. It's exactly like system model. So now let's say that so in other words, if I'm going to do optimization, et cetera, on it, it treats it just like system model, except many of the parameters have already been frozen, which you can also do with system model with your crazy set system model thing, right?
Yeah, I mean, they are, okay, so System Modeler has a notion of parameters that we need generally in the Wolfram language too, which is that a system model always have some value for the parameters, but we still know that they're parameters.
Yeah, I understand. I got it.
Okay.
I got it. So, I mean, my point is, it seems to me this idea, you know, like instead of the horrible system model set, which I hate, we could just have a thing where you wrap system model around a system model and do the same kind of thing that I'm proposing here to provide further specialization. Do you see what I'm saying?
Yeah. We're going to have to
Think about that.
Yeah, we have to think about that and work through it.
Yeah, okay, fine. Okay, but let's go through what the output is.
I think it's doable.
Right. Let's think about the output here. So we've got system model surrogate. And then it seems to me, both for system model and for system model surrogate, you need to be able to peel off an interpolating function or a parametric function.
Mm-hmm.
But you got to peel that off for a particular variable or set of variables, right?
Right.
Okay, so I'd like to propose, let me take a look at this. Probably not going to work. So, I mean, a possibility, I'm not sure it's right. See here, the generative function has the variables in it, right?
Mm-hmm.
A possibility would be or actually a system model even here. And then the parameter variables. I don't know, that might be crazy.
I think it's crazy. We're trying to use this function broad, so it's using parametric convex optimization too. Parametric function.
Okay, so here's another possibility.
And it will be used in other future functions. Parametric.
What about something like this? System model function that then returns an interpolating function or a parametric function. There's a function that extracts that from.
So that's just define. I mean, that's just kind of syntactic sugar on top of what we have.
Yes, it is. But I think it's easier to understand because that way, you know, it isn't just syntactic sugar because you've got a bunch of mess about what parameters are, what's fixed, what's not fixed, et cetera, et cetera, et cetera. And this does seem like a very useful thing to be able to do, to peel off from a system model that's doing very complicated things, to peel off a simple interpolating function, for example.
Yeah.
I mean, we have system model parametric simulate.
What does it do? What does it return?
A parametric function.
Okay, but the thing that you've skewered yourself on is there's no simulation involved in the surrogate case, right?
Right, exactly.
So that name isn't right. So what is the name of that function again?
System model parametric simulate.
Okay, but system model simulate returns system model simulation data. What does system model parametric simulate return?
Parametric function, yes, parametric function.
That's not very consistent, is it?
Well, this one, it's very you can see that it's very restrictive on what parameters do you want sensitivity.
Yeah,
or
I
parameter.
understand, but I'm saying it's not very consistent in terms of, you know, the fact that, okay, system model simulation data.
It's kind of like a tabular. I mean, it's like a
Okay,
gazillion
may I make a
named-
suggestion?
Mhm.
Okay. Maybe this is crazy. But seems to me that a system model, if pre-processed, you know, it can be oh shoot, I'm over time for another meeting, which is kind of an important meeting, but let's just try and take this for another couple of minutes and I gotta wrap.
Okay,
Yeah.
then we continue it.
Okay, so what I'm saying is, system model simulate is at some level a no-op. It is a pure optimization. Am I correct?
I mean, why you say that?
Well, it doesn't, the thing it returns,
I mean, it's like ND-solve. Do you think ND-solve is a no-op?
no, because it's returning a very different kind of object than it started with. Whereas here, what you get back from system model simulate
It's very
is
different from what you started with. You start with a model and you get data. It's the same as ND-solve. You start with a model and you get data.
all right. Well, maybe the thing we should be doing is instead of returning system model simulation data from system model simulate, we should be returning the same kind of thing that system model surrogate returns. No, I'm sorry, that system model surrogate should return a system model surrogate object. But
Yeah.
there should be a function that goes from a system model or a system model surrogate to these things that are more in the function world. Does that make sense?
Yeah. I mean, I think we almost have it. We could probably do this and we can nail it next meeting.
All right, fine. So, I mean, something like system model function. I'm not sure if that's quite right.
I mean, you're not off on anything. It's just that there's like a puzzle of things that we don't want to like.
I know.
Okay.
And I'm just concerned. I'm concerned about the way the parameters work for these parametric functions and how, where the system model function, you know, when it returns an interpolating function versus a parametric function, you know, et cetera, et cetera, et cetera, how many levels of currying there are, all
Yes.
those kinds of things.
Right.
All right. Well, okay. So let's take this for another time. And
Okay.
this
We'll
is
get this.
clearly something. Hold on. This is. I just wanna
Yes,
know
you're
what
gonna
this
have
is.
opinions about that, and
Yeah. Well, this is a nice thing to have to encapsulate these crazy C.X things.
well, you asked for it. We did it for you.
Oh, nice.
Okay, this is for you, my friend.
I
It's a very
don't
nice
know what, I
gift.
don't know what ethnicity or whatever culture that's going from, but yes.
Just a
Man.
deal for you, my friend.
Okay. I think I understand that culture.
Okay.
All right. Good stuff. Okay. And Roger, don't forget, in 1 hour we have
No,
another design review.
I'm it's just an update this morning. I'm sorry. So
Okay. All
All
right.
right.
Talk to you all soon.
talk to you then.
Bye.